What if I told you that within every atom of your body lies a universe of unimaginable power, the same power that lights the stars and fuels the sun? That's the world we step into today, nuclear physics and radioactivity, a field that explores the very heart of matter and the energy that binds the universe together. Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll uncover how nuclear physics, one of the most awe-inspiring branches of science, continues to shape our world through energy generation, medical technology, and artificial intelligence. You can watch the complete physics playlist by clicking the link below in the description. This topic is part of our section Classical to Modern Transition, Control, Fields and Motion, where we explore the powerful forces that connect matter, motion, and energy. The discovery of the atom's heart. For centuries, the atom was thought to be indivisible, the smallest piece of matter. But in the early 20th century, physicists like Ernest Rutherford, Niels Bohr, and Marie Curie shattered that idea forever. Rutherford's famous gold foil experiment revealed that atoms are mostly empty space, with nearly all their mass concentrated in a tiny central nucleus. Soon after, Marie Curie's pioneering work on radioactivity showed that atomic nuclei are not stable but can spontaneously transform, releasing energy and particles in the process. This discovery opened the door to the most powerful source of energy ever known, nuclear energy, and one of the most important fields in modern physics. Understanding nuclear forces. Inside every nucleus, two immense forces are at play. The strong nuclear force, which binds protons and neutrons together. And the electromagnetic force, which tries to push protons apart. The delicate balance between these forces determines whether an atom is stable or radioactive. When that balance breaks, the nucleus emits radiation, in the form of alpha, beta, or gamma rays, as it transforms into a more stable form. This process, known as radioactive decay, is the heartbeat of nuclear physics. It's what allows scientists to date ancient fossils using carbon-14, produce medical isotopes for cancer therapy, and even understand the internal reactions that power stars. Energy from the atom, fission and fusion. There are two main ways to release nuclear energy, fission and fusion. Nuclear fission occurs when heavy nuclei, like uranium-235, split into smaller parts, releasing huge amounts of energy. This is the process that powers nuclear reactors and some of the most devastating weapons in history. Nuclear fusion, on the other hand, is what powers the sun. It fuses light elements like hydrogen into helium, releasing even greater energy. Scientists are now developing fusion reactors to create clean, nearly limitless energy, the ultimate dream of sustainable power. The balance between these two processes defines humanity's relationship with atomic energy, both as a source of progress and as a reminder of responsibility. Radioactivity in medicine and science. Far beyond energy, nuclear physics has transformed modern medicine. Radioisotopes are used for imaging organs, diagnosing diseases, and treating cancer. Techniques like PET scans and radiotherapy rely on the controlled use of radioactive substances to see and heal the invisible. Even in agriculture and archaeology, nuclear methods are used to track nutrients, study soil, and determine the age of artifacts through radiometric dating. Every click of a Geiger counter tells a story, not of danger, but of discovery. AI and the new age of nuclear science. Today, nuclear physics is merging with artificial intelligence to revolutionize how we understand atomic behavior. AI systems analyze massive datasets from particle detectors, predict radioactive decay patterns, and optimize reactor designs for safety and efficiency. Machine learning models now assist in nuclear medicine, improving image clarity in PET scans and identifying anomalies in radiation data faster than ever before. Even in fusion research, AI helps stabilize plasma, one of the biggest challenges in achieving practical fusion power. The same intelligence that learns from images and language is now learning from the nucleus itself. The power within. Nuclear physics teaches us something profound, that even the smallest things in the universe contain unimaginable energy and complexity. It's a field of both creation and caution, capable of healing and harm, of powering cities or lighting the stars. But most of all, it reminds us that understanding the forces within the atom is key to understanding the forces within ourselves: balance, transformation, and energy in motion. This is the Learning Studio, and this was our episode on nuclear physics and radioactivity. If you enjoyed this exploration into the energy hidden within matter, make sure to subscribe, like, and check out our physics playlist linked below. In our next episode, we'll dive into the grand unification of modern physics, quantum field theory and unification, where particles become vibrations, and the universe becomes one interconnected field of energy and information. Because in physics, even the smallest particles can hold the power of creation.